All right, so let's begin. Last time I did like integrating the net with the what do you call that? The just the bot web page, so you can like play against the neural network, and it's just the vanilla neural network. And like I was very like after end of the stream, I was extremely dissatisfied with that because what happened was like I was kind of copying and pasting like especially net.ts and changing stuff like between the discrepancy between like I guess the game states like between certain files and like certain expectations. Just like we have like two repositories, two repositories, the BumperCoins and BumperCoins bot, and like we were kind of like we took a detour, like well we took like nested detours, like a detour off detour, whatever, like lots of detours, and the detours themselves have detours in them, and like we kind of like copied some stuff from BumperCoins into BumperCoins bot repository, and then like there was a bit of a divergence. So rather than and then like after we kind of like at least we haven't even done AlphaZero yet. I mean, we haven't actually ran any training, but like in theory, we've kind of like got it set up. Like it compiles, right? Like if we go to like BumperCoins bot and then like do like TSC, well that's Scratchpad. Let's just take that and like replace Scratch. Well, let's just run this, make sure it compiles. And then like do the same thing, but for train.ts. So in theory, train.ts compiles, and like we've run, and train.ts is basically like almost a verbatim copy, and MCTS, all these stuff are like every single file in BumperCoins bot is basically sourced from like the Connect4 repository, BumperCoins repository, and just those are the two main sources of that, and of course TensorFlow, but which we installed from npm. But like what I'm saying is that like BumperCoins bot has like some files, right? It has some code. And like once that code is kind of like solidified, then we don't want to maintain two copies of it, right? So it's better to like take this whole BumperCoins bot, or at least all the TS files, which I did, and I copied them into BumperCoins. So now we don't have to like, so that's kind of like the idea, right? So like if I go back to BumperCoins, then like right after I finished the stream, or well actually the day after, I kind of like realized that my approach was probably like misguided. So like and also like actually I'll give the motivation, like not just like kind of being clean and like kind of only having like not repeating myself in terms of code, but like in terms of like in terms of like reuse, because right now like let's take a step back. Like what do we have, right? Like if I just like do a run.sh and like play against the spot, like wait, what CP client bump? Okay, that's a directory. Well, I copied differently. Oh, sorry, bot. Right, like right now, it is just like it's making moves, and these moves come from neural network. Like if I like kind of go to network, and then kind of do that, then you can see it's loading in the model.json, the weights.bin, and so forth, right? So yeah, so this is basically what we have. We're just like playing from the bot. It's a vanilla neural network, right? So like vanilla neural network, I mean, we already talked about the context of Connect4 too. It's just we have a game state, we give it to a network, and the network tells us like a policy, and we just choose the move with the highest probability, right? And that's what's currently happening. But in the future, I'm thinking like I'm kind of, I guess, inspired by like, well, not inspired, but like I kind of want to imitate what we did in the Connect4 detour, where I created like the Connect4 webpage, where like the end product was like you let the user specify like when you're playing against the Connect4 bot, what's happening is we're not just like doing the vanilla neural network. Instead, we're running MCTS. And it seems that like this neural network runs predictions pretty fast, just like 1 or 2 ticks, 0 to 2 ticks. So if like there's 60 ticks between moves, it can do like maybe like 30 to 50 or 30 to 60 predictions. So maybe we can like actually run MCTS, right? Like Monte Carlo tree search in our BumperCoins bot as well. So to do that, like right now it's using vanilla, and like the previous approach, which I did on stream, was like copy net.ts and made some changes. And like, do I really want to copy mcts.ts and like make more changes too? Like instead of doing that, like we already have Monte Carlo tree search in our BumperCoins bot project. So like I believe like we should use code reuse, right? So what I did, git log, is I used, let's just make this full screen, is I basically so last stream was like I ended on this commit. And then I fixed a bug on it afterwards, like right after the stream, like 6:30, like half an hour later, I fixed a tiny little bug in that thing. And like, cause basically like here, never mind, it's a pretty trivial bug, but like I wasn't setting the max prob move anywhere. That's why like it was only moving one coin one direction. But anyways, that's irrelevant because the next 2 commits are just reverting. So like last stream I did this, then half an hour later I quickly fixed a bug in this. So these 2 basically are like the work from last stream. And then what I did was I reverted both of them in proper order, reverse order. So now, so like after this commit right here, like the second revert, we're basically left right here, like before the stream. And then I did alternative stab, right? So now let's actually have a look at like front-end client. So if you look at front-end client, there is a new folder here. It's a BumperCoins bot, right? So ls front-end client BumperCoins bot. So I basically like kind of copied all the TS files from BumperCoins bot. In fact, I can just copy the whole directory, but I just like kind of like dumped BumperCoins bot in like kind of like a sub module or like a sub. It's like a nested directory basically. It's kind of funny how like now BumperCoins bot, like there is some, it's kind of like a, I guess an incestuous relationship between all these, like these 2 repositories. How like BumperCoins bot has fixedpoint.ts, and like if I do like ls shared, like a lot of like game state, a lot of these stuff like files are kind of like intermixed. Like we have multiple copies, but like ultimately BumperCoins bot will just be kind of like the source of truth for bot stuff, I guess, in terms of like bots. So like BumperCoins bot, like there's only one main difference, and that's if you look into like net.ts, then like, well actually let's just actually like go back to this commit, like this commit which I did off stream, like after the two reverts, I actually like kind of like did an alternative stab at integrating bot neural network with bot page. Whereas the first commit from last stream, or the final commit from last stream, was, wait, what? Sorry. Git log. Initial stab at integrating bot, like this is basically copy paste. I had initial stab and then I reverted it because I realized it was stupid, and then I have an alternative stab. So now let's actually like have a look at the difference between like what this commit entails. So I think we use this commit first, the one before any stab. Just copy that. And let's just paste it there. So basically right now I'm about to show like the like my new approach that's better, superior than what I did last stream, which basically reuses the code in BumperCoins bot. Like it doesn't copy the code, it straight up uses that code with one little twist, which is very, very trivial. And here's the twist. So front end, so right here in git ignore, we can ignore the git ignore, who cares about that? Yeah, we basically git ignore, we're just kind of like some output files, we're just ignoring the stuff in BumperCoins bot. But now here's the crucial file, bot worker, right? So here, first thing first, same thing we did last stream, we import TensorFlow. But notice that in net. And we're also like importing stuff from this nested directory. Like it's not like // in the name, but / BumperCoins bot, because we're going inside that folder, game state, right? So like we have like import game state from / game state, and this is import game state from the different game state. So like these two files are very similar, but there is some difference in them. And but then notice I have to do game state. I have to use the as word to kind of give it a new name, to rename it, because we can't have like two conflicting game states. And also like import get policy and value, which is the exact same function net.ts in every net.ts, both in Connect 4 and in what do you call that? Yeah, BumperCoins bot. So basically like the crucial thing is right here. We're basically like copying stuff from BumperCoins bot, so we're like verbatim using the existing code. So we only have to maintain one copy in BumperCoins bot. That'll be the source of truth, not just for these files, but also for neural network too. And whenever we're going to test them out, we just CP or CP/R recursively, just copy all the files from BumperCoins bot, and then boom, we get it. We get the work for free. With one twist, in net.ts, it basically imports TensorFlow TFJS -node -GPU, right? Because we're using the backend, like the GPU backend, when we're doing the training. But then I have to go to net.ts, this file here, and I have to edit TFJS/node GPU to replace it with like this line itself, just to use the regular TFJS, so that like the browser can also use it basically. And bundle, so Browserify can bundle it. We've seen this issue come up before, but Connect 4, very trivial. But aside from that, we can basically leverage existing code in BumperCoins bot. Okay, so how does it do it, right? Same thing, load model, similar to what we did last stream. And then I call that get random move, same thing from last stream, nothing different. But here's the crucial thing. What we do is we convert game state. So like the web page gives the web worker, it passes it in the game state. And what it does here is it takes the game state, which we got, and we're converting the game state to a bot game state, right? This bot game state. So what's the difference between a game state and a bot game state? Like the main difference, I guess, is the bot game state has a property called like is P1 turn or something. Yeah, bota is, so like that's the main difference. Aside from that, it's basically the same. So let's look at this convert game state to bot game state. Convert game state to bot, actually let's pretend that this works. Then what we do is from this bot game state, we get the bot move using net.ts. How? Well, we call get policy and value, our good old fashioned, our trusty get policy and value, which we imported from net.ts right here in BumperCoins bot. So then get policy and value, we pass it the game state bot. Remember, get policy and value takes a game state bot, or bot game state, sorry. Yeah, this is bot game state, but then this says game state bot. I guess I should choose a convention. It's trivial. So get policy and value, game state bot, and then pass in the model too, which we made sure it's loaded. And then we do 0. Why? Because get policy and value returns a list with a tuple with two elements, the policy and this index 0 and a value. So we just get the policy, so 0 indexes into it and gives us the policy. Then we get highest prob move. Get highest prob move is just we've seen this before. This just gives us the highest move. This is again like from net.ts. So that gives you a bot move, and then we have to convert the move back into like a regular move. And that's almost trivial. The main difference between like moves are just the move ID, and that's it. So let's look at convert bot move to move. We just return a new move. We just pass in the bot move's coin ID, the velocities, and that's it. The only main difference is the bot move has a move ID, which in fact we don't even need. That's only, well, actually, never mind. Yeah, that's mainly used for training, I think. But anyways, let's look at other differences. Oh yeah, see this diff? The front-end client BumperCoins bot coin dot, wait, no, never mind. There's some new files. And then like the rest of the diff is just kind of copying over all these new files, where we're just kind of like copying over like, yeah, never existed from nothing, and then from like the thing itself, just new files. Where basically the rest of the code is like just copying and pasting the BumperCoins bot directory. I just copied and pasted those files. So let's get rid of them. So now the main thing is so let's kind of go back into this conversion, right? So basically like the idea is that we're given the game state and we convert the game state into something like this game state is native to BumperCoins, and we're converting it to something that's native to BumperCoins bot. And after that conversion, we can leverage all the features in BumperCoins bot to get the move and then convert it back, and then we're done. So these conversions let us, like, it's like kind of like matrix, like various kind of like matrix operations where we like do like transform to like a different domain. Then we do the operation we want to do. Then we have to do like transform inverse to like go back to the original world. Like we go to like, it's like those like like those anime where like you reincarnate into a new world. It's like you go into like the new world, you get some stuff done, you get some like wisdom, some abilities, whatever, and then you go back to the old world. I guess that doesn't really happen in those comics, but anyways, so yeah, like you can word it back. So now how does convert work? So now like we first instantiate the new bot game state, and then this is pretty crucial. We set the is P1 turn to false because the bot is P2 by our convention, and then we transfer the coins. I was kind of concerned that this might cause any compile errors, but does not cause any compile errors, and it compiles. In fact, we just saw it. We just did run.sh in the beginning, so I play the bot, and then and there's some dumb new lines, which I should delete, and we just return it. Now, why can we do this? My guess is like the coin.ts file in the BumperCoins bot coin is actually verbatim the coin.ts in like the shared coin. Like if I go like diff, yeah, if I just do like less frontend client BumperCoins bot coin.ts and look at this and compare it to like sorry, not frontend, shared coin.ts, I literally copied it. Like they're the exact same, like diff with shared coin.ts. You see, there's no difference. But like here when I'm converting, like, but move, there was a slight difference. Like move, the main difference is that BumperCoins bot has a move ID, which the regular move does not. So like if we take the same diff command, but we replace it with the move.ts, and we look here, you see that? There's some difference. So like in the move.ts, we have like this new line, which is move ID number. And then the constructor is a bit of a difference because in the BumperCoins bots move, this constructor has this additional move ID. Everything else, like if you compare this line with these two lines, like it just also has a move ID. And then, so like this one has like this and this, but it's replaced with just the constructor without it. Actually, let me just actually reverse the order when I'm doing this diff. I want to show it from a different perspective of shared move.ts. Let's just do it clear. Too messy. So again, like the move.ts here is like we have a move ID, and then or like sorry, like this was like the point is that there's a move ID, and also that there's also a clone too in BumperCoins bot. But aside from that, like the difference is not that much. But still, that's why we have like but that's why like we have move as bot move, but then because the coins are the same, I think that this line just works. So like basically like this is like it's not that much work. It's much more elegant, or it's much more efficient reusing the existing net.ts code rather than copy pasting it and making modifications. And then I'll end up having like 2 copies of net.ts to work with rather than one source of truth. And also because like we're using this, we can also use BumperCoins bot. We can also import like Monte Carlo tree search too. And then like remember I said like maybe like I can do like 50 predictions or something, 30 to 50 predictions, and that might give me some time. Like I can like maybe like have a GUI or like have some player settings where like the person playing against the bot can like have a slider or something like in Connect 4, like it has a number input where you can enter how many like number of Monte Carlo simulations you want to run per each turn. So if they have like a high-end device, then they can like increase that number. But then if they have like a cheap Chromebook, then they can decrease the number or use maybe a vanilla neural network with just 1 prediction per turn, per bot turn. So like the idea is that like I'm also thinking in the future, if this like right now, like we're gonna train, well, hopefully train and get some neural network that can like play the game. But if it's too weak, then we might consider like also doing Monte Carlo tree search as well, rather than just using the vanilla network where we just like take the network, like take the game state, take the converted game state, take the model, and just like run a prediction and return the highest move. And like if playing against that bot is kind of like weak or like it's not like good enough, then maybe it might make sense to run Monte Carlo tree search, give some depth to it, to hopefully boost the policy, like basically leveraging the same Monte Carlo policy improvements to getting a better policy, and then calling like the policy which we get will be even stronger by using some depth to it, by considering future states. Like, hey, I make this move, the bot make this move, human makes that move, I make this move, and so forth, and doing tree search to kind of refine our understanding of refine the understanding of like the Q values. I mean, just like getting a stronger policy. So that's kind of like the idea. Like in the future, I may want to like import like Monte Carlo tree search or like get move or something from BumperCoins bot MCTS, and in the future we can just reuse that code to get an even stronger bot. So that's why it's kind of a good idea to like just kind of copy the whole directory, so we can just like have the ability to reuse it. And again, the only difference after copying it is we have to replace all these lines like with this. Whenever we have import star as TF, like when we're importing TensorFlow, the BumperCoins bot, like for example, if I go to like, let's just go back to BumperCoins bot because we're going to work on that for the rest of the stream, like lsnet.ts, or sorry, less, not ls. Like you see this has like import as TF from TF like no GPU, right? Like after copying it, I deleted these lines. And once I copy MCTS, again, I'll have to like delete those lines too. Because again, like the GPU stuff, like we can't, like we have to only use this because we're running it in the browser, right? So that's like the only difference, I think. I mean, hopefully, but we'll see. But anyways, so like this is basically like a good like kind of stopping point, not for the stream, but just for like just to establish like this new method of doing the integrating like basically like this is like the end of like correcting last stream's approach. So yeah, rather than like copying and pasting stuff and editing them, instead we can just like use the code as is, and the only difference is we have to make a conversion, and then that lets us do it. And also when we're importing stuff from that code, because like they share like the same names like game state and move, we have to rename them as like bot move and bot game state, and that's all. And then when we're importing, we have to add an additional prefix to like go into the directory of which to find them, or just to specify their location. So that's basically the idea. We just copy and pasted stuff. So now it's kind of funny how like BumperCoins bot has files from BumperCoins in the form of like they're like kind of like game state BC for BumperCoins and game state like all these BCs and CFs for Connect 4. And all these stuff are like kind of like a whole mix match of stuff in BumperCoins bot, which we copied from BumperCoins. And the funny thing is now that we copied everything back into BumperCoins, it's like there's so many copies floating around. But the whole idea is to treat this as a module basically and just accept it as true. So that'll be a source of truth. So now all that's left, which sounds simple, but may take a long time or may not even be possible, is to train our bot. Okay, good. Let's open up a VS Code on here. Okay, I haven't done this in a while. Okay, yeah, I know we were doing some like kind of printing with Scratchpad, and I remember like kind of being satisfied with it. Let's just kind of Let's just kind of copy this line here. Paste. Let's compile that with source map, and let's just do the same thing but for train.ts as well. Okay, good. So now we kind of like finished the BumperCoins detour, and we're back into the familiar BumperCoins bot world where the idea is we want to call node train.js or like run train.ts. And each time we run it, the neural network should get stronger. And again, this is going to be my first time testing it. Like this is good, probably like troubleshooting and finding bugs too, but let's, I guess it's all leading up to this, right? Node train.js. Now, one thing I think to do is let's just put a breakpoint here so I can like see how many examples we get. And let's just go to Monte Carlo tree search and like maybe like take all these numbers and let's just make them like super small, like just one, like the smallest we can. Let's just have one iteration. Wait, what does num iterations mean? So each iteration we run some games, like the number of batches and nums, like this is like the batch, like number, how many batches, num games per iteration, the batch size, like each iteration, how many games do we run? Let's just make that one. Okay. Now let's go to our MCTS and like change those numbers too to make them small. So then here, see how many simulations do we want? 1,000. Let's make that small. Let's make it like what is the Sagar Scenario Nares like Othello? Or I think he uses 25. Okay, so then like the K, like the move factor is 24, right? There's 3 coins, and each can have 8 directions. So 3 times 8 is 24. And then let's just have depth 2 maybe. So 24 squared. Let's say 25 squared, 625. Let's make it 500. So let's cut it by 2. Okay, let's like recompile it. Symmetries, let's just review symmetries again. Move. Okay, yeah, that's cool. Like again, like Connect 4 only had 2 symmetries, like, or well, 1 symmetry aside, like let's not count identity. But here we have flip horizontally, vertically, and horizontally and vertically. And again, vertically and horizontally, like I don't think the order matters. Like they both result in they both transpose to each other. So it's just 3 symmetries, not 4. Like there's no flip vertically and horizontally. There's just horizontally and vertically. That is the same as vertically than horizontally. There's some like independence to them, orthogonal x and y's. Okay, good. Let's just do a quick git diff, make sure we didn't change anything. I mean, we only changed the numbers. From 1,000, we made it less. And from 200, we made it 1. And there's one concern I have, which is like the feasibility, how long this takes to run. Like I'm like dropping it down to 1 just so we can like just play one self-play game. Because one thing I'm worried about is infinite loops. Like what if like player 1 moves here, player 2 moves here, player 1 moves back, 2 moves back, and they keep repeating forever and we get an infinite loop. So maybe like, I mean, we'll see if that happens. Like one possibility is adding some decay factor, like we decrease the king's health until like it becomes a draw. Or we can have like a max number of ticks where like if the game runs for like some number of moves, like 1,000 or something, then it just aborts it and calls it a draw or something. So maybe like that's a possibility. But we'll see. Hopefully with the policy refinement, I mean the Monte Carlo tree search policy improvement, we can kind of not have to do that. Whereas in Connect 4, there is no worry about infinite loops because every time a move is made, some cell is occupied and there's up to 42 cells. So like eventually, even if both bots play like the worst, like the moves to keep the game going the longest, it's capped to 42 moves. After 42 moves, if the game is not decisive, it ends in a draw. Like there is some advancement, some progression in the overall trajectory of the game. Like every time you like fill up a coin in Connect 4, like we're one step closer to the end of the game because like one cell is filled. Whereas BumperCoins, it's not necessarily true. Like it can just go on forever. So I am a bit concerned with infinite loops. So then like that's something to keep in mind. Maybe we can have a decay factor by like every tick, like the king's health decreases by like some very tiny epsilon or something, which gives us like an upper bound of moves. Or we can inject some randomness too, like some noise, some randomness too, like we don't like with like 98% of the time we follow the moves, the policy that the MCTS search gives us, but 2% of the time we choose a random move. So that randomness should also break the infinite loop too. So like those are some possibilities. Just brainstorming off the top of my head. But yeah, let's get started. Let's set a breakpoint here. Cause like my thing is I want to kind of like run one game of self play and see how many examples we get, which is like how many turns it took to get decisive. So yeah, let's actually run this. Again, first time. So like we'll see how it goes, right? Again, like a lot of this stuff's completely untested and we've never been tested trained. So like if we catch errors, we have to find them in the debug console, I believe. So okay, let's actually go to debug console and let's click run debug. Node.js. First time. Okay. It's running. It's running. It's running. It is still running. Okay, I'll put some breakpoint like I'll go to mcts.cs maybe. Let's move this. I'll just put a breakpoint here. Okay, we called it. So let's just keep running. Okay, let's just look at the game state. Print or something? Print. Wait, what's this undefined? Okay, right, yeah. So everything is full health. One means full health. Okay, let's just keep playing. Rather than doing that, let's just kind of like do this and let it run some more time. Okay, so it's running. Like we can see that the bots are like the coins are moving a bit. Okay, let's put a breakpoint back. Let's print it out, see the status of the game. Okay, see. So now like these coins, I'm guessing, have hit the wall or something, and now their health is no longer a 1. So like player 2 is kind of like, okay, so something is happening. But I want to see the coins collide, you know? Right? Okay, I wanted to see how many examples we have so far. Oh no, we're still in self-play game. Let's kind of go into that. Let's put a breakpoint right here. So how many examples do we have? 38. Okay, it's only been like 38 moves. So I guess prediction's kind of slowish. I don't know. Just 38. Okay. Actually, I think this is the breakpoint to have. Let's remove this breakpoint. So let's just remove that from here. Sorry, remove. Let's go into yeah, here, and then let's do a game state. Game state.print. I hate how like they have like these. Okay, fine. Wait, there's only like. Oh, whatever. Let's just continue. Let's just deactivate. Which line is 55? Oh, it's like kind of highlighted. Yeah, I'm not used to using VS Code. I mostly only code exclusively in Vim, actually. Okay, so it's running. Again, this is all one game. One self-play game. Like Connect 4 would have been done, like it would have done like 100 or 1,000 games by now. Or I don't know. Or many games. Okay, it's okay again, like this is just how it works. Like initially when you're running training like for Alpha 0, like initially the bot is like purely random. So like the moves it makes are really stupid. And like that means the games will take a long time. The bots might have been like the kings might have move away from each other, or like what am I saying? The point is that like the stronger the bots get, like the more decisive, like they basically will move with intention. Like their moves will be more precise, more to the point, more direct, more confrontational. Or maybe I'm just ascribing human qualities to it. But I believe that like as the bots get stronger, like the game should end faster. Hopefully. Okay, let's like set this breakpoint back on, turn it back on, and look and let's print out our game state. Okay, so like the coins have some damage. Let's let it run. Well, let's see how many examples we have. So it's been like 80 moves, and like the coins still have lots of health. Or actually, let's just see how many coins we have. Game state dot coins dot length. Okay, so like none of the coins have died, and like, okay, keep running. I guess we just wait, right? I mean, one thing I feel like doing is like putting some breakpoints like inside Monte Carlo tree search, like the search function, just to like kind of like simulate the actual Monte Carlo tree search, like just to like debug and step through and like watch everything like working. What's this thing right here? This icon? I don't know. Well, it's still running. I'm just waiting. Okay. I mean, yeah, maybe I'll have to wait for like a year before this training ends. I don't know. I mean, if the stuff takes too long, what I can do is like I can try decreasing the complexity of the neural network, like remove some layers or something. Or like instead of like using number of moves as 8, maybe I can like make it 6 or something. Okay, it's still going. Let's inspect the game state right now. There's still 6 coins. Okay, but their healths are like gone down a bit. Keep going. Okay, while this is running, maybe I can like do some leak code or close some tabs. You see, the best part is now we don't have to do web work or debugging anymore because we're basically like getting it for free from BumperCoins bot. Like we know that net.ts works, or like I mean or even if we don't, like the way we test it out is we test it in BumperCoins bot and not in our web worker thread. Like if BumperCoins bot works, then we get all of it for free. The stack stuff. So, oh yeah, I have to do that. Wait, okay, no. This is wrong. This is wrong. This is wrong. Let me just break out of this. I also have to. Oh wait, why did I do that? Yeah. I mean, well, never mind. No, I realized something. I had to like some of the work I did last time, where the previous stuff, I have to redo that since I reverted it, like passing in a link to previous game state. So yeah, that is a bug. I mean, that is something incomplete, so I do have to do that. Okay, so I think for now I'll just kind of actually stop and like just get that to work on my own time. Or actually, no, let me just quickly do that. I don't know. I kind of feel like ending it right now. I mean, the main thing I did this stream is just kind of talk about a new way of integrating the net with the game. Get status. Let me just quickly do cd hero get status. Get diff. Oh yeah, I can decrease this number too. I can make this much less too, just to make the games end faster. Okay, I mean, I'll just leave this uncommitted. I won't unstage it. I'll just leave it unstaged because I may change these numbers. Yeah. This is what I did last stream. I mean, cherry picking a commit like takes the whole commit, but what I want is part of the commit. Oh wait, no, what am I doing? Can I do git diff like uff like something? Like, can I do the git diff from like just bot? Oh no, here is bot's first one. Actually, let me open up a new tab, right? Front-end, client, bot. Just bot.ts and bot worker.ts, and that's it, right? Yeah, exactly. So let's go to bot.ts, and then I'm just gonna straight up copy and paste it. I'm not proud of this, but it's just a quick thing. Yeah, I forgot to do that. Okay, so now we're holding a sliding window in array deck. I mean, a list, like we're using as a sliding window of like size around 30. And then, or 20, I'm not sure. Or is it 31? So if I'm at like state A and I advance to like 4, B, C, D, E. Oh, I think it should be size 31 maybe, I'm not sure. Then bot worker.pass, 2D pass. So in restart, we kind of flush out. We flush out, we just kind of clear out. Let's go to restart. First, just to see it. Flush that thing out. And then what? We pass in, instead of game state, we make it the game state and then like something 30 ticks before. Like if you're like size 4 or size 5, then 4 ticks before is like 1, 2, 3, 4. So you go 1, 2, 3, 4, 1, 2, 3, 4. Okay, yeah, that makes sense. So yeah, I think it should be 31, not 30. So bot worker post message. Where's your post message? Where's your post message? Where's your post message? Which line is this? A line like 117, 120-ish. So right here, we replace that with the list. Ah. Oops. So we added past game states, and then we flushed it out. 122, or so we wrap it inside a list. Then we do like the, what do you call it? That thing of 0. Okay. And now we do the, actually, wait, why did I stop? Actually, I should not have stopped it. Actually, why did I stop it? Because that has nothing to do with, this has nothing to do with that. I don't know why I stopped it. Okay, in fact, I'll take this moment to just make this like a smaller number so I can hopefully finish faster or advance faster. If it's 24 moves, what's 24 times 2? Well, 25 times 2, 50. Let's make it 50. And now let's just go back to train.ts. And let's just, oh, we have to recompile it. Recompile that. And now we click run and debug. Okay, this should make it run much faster. Let's set a breakpoint here. Debug console. Game state. GameState.coins.length. And let's just leave this running while we fix the like incorporating the previous game state code. Okay, well let's just do that. Okay, so now what was I doing? What was my last thing? I said added past state to 0. There, good. An update, we have to like make it. I'll replace 30 with 31 and update. Update. Oh, these stupid plus signs get taken into place. So then we made it 31. Because again, like the difference from the game state and like the first one should be like 30, right? Like cuz like this one we advanced 30 times to get that one, right? Well, it's either like 30, 31, it's off by 1. It's not such a big deal. I mean, all this is approximations anyway, so it's not even a big deal. We could just make it back to 30. Or I don't know, it depends on like never mind. Let's just make it 31, whatever. It's just off by 1, worst case, or off by 1 or 2, not a big deal. And then clone, and then that's basically it, right? And now let's go to bot worker. So you take these two lines right here. Bot worker. So our game state is now on e data of 0, right? Zero. Game state is e data of 0, and then prev game state is just that, but e data of 1. Okay. Copy that line, but then make it prev game state bot. Prev game state. And then game state bot dot prev game state equals that. And now that we did a link, then we can actually do the prediction on it. Okay, I think that's all. That's all I need. Get diff. Clear. Get diff. Okay, so then we added this new thing, like the window, which is capped at like 30, 31. Well, yeah, 31 max. Then we flush it out when we restart, and then when we're posting it, we take the current game state, and then we also take like one thing around 30, 31, around 30 ticks ago. And the update, what we do is the first thing we do is we clone the game state to make sure it's a new one. I mean, it's just a clone, and we just kind of dump it in the past game states. And then if we're exceeded it, then we just shift everything. We just pop off from, it's like an array deck where we're like, I mean, a DQ, a deck where we're kind of like pushing in the end and removing from the front. So it's like a sliding window shift, exactly. And then when we're like posting, giving like our game state to the web worker, we have to also pass in like not just this is worker. When we're posting it, we're passing in the game state and like something a bit like old, like 30 ticks ago. And then when we're receiving it, we use 0 and 1. We index into data to like index into our list to get the two game states. Then we convert them to bot game states. And then we actually make the link right here. And then so now let's just make sure that this compiles. And to do that, we just like do the run.sh. If there's any compile errors, it'll show them right here. Okay, there's some errors. Bot.ts line 135. Clone game state. Okay, so we don't have, so what's clone game state? Let me just close this tab. This tab is being stupid. Status. Okay, so clone game state. It's kind of like this thing plus. Okay, nice. Well, I just pressed C to confirm it, but yeah. Okay, so I think that should work. Let's make sure this works. I know I copied this from like I think Game State Provider or something, but remove the flip coins thing. Board. I mean, I did it last stream, but let me just double check. So we do that. New. Then it's P1. Just okay. This is a very stupid line, but that's because there was a switch. Then coin is P1. Clone. Make sure everything is cloned. The fixed points and king. Okay, fine. That looks good. Then wind, again, we have to clone everything. That's crucial. Then ID, okay, fine. We push, oh, wait, there is no wins. Who cares about that? Obstacles, clone. Okay, yeah, that looks correct. Okay, let's quit out of that. Clear. Then we want to just run everything again. Come on, compile. Okay, great, it compiled. Get status. Get diff. So we do this, we do that, we do this, and then we just shift it. Like if it we add it, like we add to the end and remove from the start. Like we're shifting the sliding window, and then we did a clone, and we're basically using the clone right here, and then that is all. And then we talked about this thing. We basically convert not just the game state, but also previous game state we passed in both to bot game states, and then we just do the link so that like the neural network is able to use both the previous game state and game state's coins when it's doing the prediction, when it's converting to image stack. Okay, that's get diff, or sorry, get status, get add all, get commit. What should I call this commit? Not should use a prev game state as well when, yeah, or use whatever. That feels prescriptive. Use. Okay, great. Now let's go back to VS Code and look at our progress. Oh, it finished running. Wait, why did it finish running? Wait, did it just finish running? I mean, the process, I mean, it's not running anymore. But like it didn't hit this breakpoint. Did it quit or like what happened? Let me just run and debug. Put a breakpoint here. Run. Okay, it's running. Let's kind of like pause it and then check our game state. Okay, now let's let it rip. That's weird. I thought that, I mean, Did I not? I thought I was letting it run, and then I did some like fixing on whatever. But anyways, okay. So now after doing this, then like this stuff I did off stream, and then like this stuff should finally correct this stuff. Oh yeah, PS. We're actually running these processes right now since it's compiled. We can actually like just play against our well, not this one, our bot again. Yeah, good. It's making random moves. So right now, neural network is garbage, and if we train it correctly in VS Code, it should start to improve and make more logical moves. Great. Let's go back here. Let's create this breakpoint again. Check the progress for a game state. Still 6 coins. Okay, the healths are going down. Great. Nice to see. Nice to see. Maybe when I'm doing this like print helper or this print debugging method, I should like truncate it to like the first 2 or 3 digits, like 0 point, like some fixed number of decimal places. Because every time you like do it, it like kind of like messes up the relative locations of the coins. All right, it's just running. It's just running. Kind of have to use the restroom for a bit. Okay, let's breakpoint again. Let's see how many examples we have. How many turns we have done? 600 turns. Again, connect 4, 42. Trading this will take a long time as well. Oh, we have to multiply by 4 for symmetries too. Wow. Okay. Let's check our progress. Number of coins. Still 6. No coins have died. I guess playing random moves is not a very effective bot. Anyways, this will keep running, and I will just use the restroom and be right back. Oh, it finished. Okay. How many examples do we have? 4, almost 5,000. How long did this take? I don't know, just a few minutes maybe. Oh, what's the outcome of the game? Who won? Okay, so -1 means the player 1 lost. But why is it like -1, -1, negative? Shouldn't it be like alternate? P1 turned true. So P1 turned true, but then it lost. 1 game state. P1 turn true. Oh, because these are 4 because of the symmetries, right? Because of symmetries, that's why. Like this is identity. Like yeah, we can actually look at the game state. Like we can actually let's just have a look at that, right? Let's like take some arbitrary game state. Like, well, no, we already did that. Like you get the point, right? Like what I'm saying is that like, sorry about that. Examples, like if you look at this one, it's game state, and then we print out like examples 0 dot print dot game state, or sorry about that, examples 0 of 0, which is the game state, print that's like that. And then what if you flip it horizontally? Same thing. Vertically, same thing. And then oh well, this one is a bad one. Let's just do example 0 1 2 3 4, maybe 4. So that's like 4, right? And let's flip it. I think what is it like horizontally? 1. Or sorry, what am I doing? 0, but then 5, right? To make it the next one. So see that? How like it has like this shape, and then like this one's a bit longer than here. Exactly, like 4 and 5. So the only difference is symmetry. Okay, so the examples somewhat make sense. Where like when we look at the examples, it shifts from like -1 1 1 1 and 1 1 1, -1 1 1 1 1. It's like 4 times 1, then 4 times -1, and so forth, alternating between player 1 and player 2. Because like the sign determines the perspective. Therefore, they're always opposite each other, except for 0, where they're all zeros. Okay, and then we just train it. Let's go. So if train, if I've not tested training. Like we've never done any testing for training in our Scratchpad. So this debug, we just wasted some time, but not too much. Okay, let's let that rip, or let's go into that. Okay. Let's just play. Number of examples. Okay, I'm gonna put everything before the model.fit. Boom. Okay, it's running. I'm waiting for it to hit here. Okay. X's, what are the shape of this? Or what's the shape of num examples? How many examples do you have? 4, 4, 8, 2, 4. What's the shape of the X's? Shape is 4, 8, 2, 4, 15, 20, 9. Yep, because 9, the channels gets transposed to the end. And what's the shape of the Y1s? Is that policy or value? I forget. It's policy. Its shape is that and 2400, because like 8 times 15 times 20, right? It's a 24, like, yeah. The flat vector, like policy to vector, becomes that, and then the next one should be 4824, 1 for the value. Yep, 4824, 1. Okay, yeah, great. So now let's see what time it is. 55. Now let's actually run the train. Boom. Oh, it's done. It trained. The losses, or wait, what? Oh, it did the train. It's finished. Okay. So in theory now, the neural network became a bit stronger. In theory, right? It took like 5K steps, or 4.8 examples. In theory, it became stronger a bit, right? So if I do like, if I like kind of like look at our diff, right? Get status. You see the weights have changed. So now what we want to do in BumperCoins is we want to like do like CP BumperCoins bot, or actually wait, no. Yeah, you see this old CP command? The CP command is when I got the TypeScript files from BumperCoins bot and I stuffed them in this thing. But anyways, that's not what we were looking for. BumperCoins bot model. So right here, we're kind of CPing into the model, and then we're copying the weights dot bin and then the model.json into our function.client like that. Get status. So now, as we can see here, the weights have changed, right? So then now when we like do run all for here, or run that, now if we play against the bot, it should be playing stronger. Proceeds to hit against the wall. Well, it didn't learn much, it seems. But anyways, in theory, this model now has new weights. It's been updated. So, like, it should be playing better. Oh, is it infinite looping? It's infinite looping. Very cool. Okay. Great, so now we just kind of debug this, and we can just run it again. Wait, no, not this one, not GameState. I have to run train.ts. Actually, why are we doing it here? Now that we have it like set up, we can actually just run it from here directly. Yeah, these are just numbers. Okay. Actually no. Train.ts. And now node train.js. Yeah, we can just run it there. There's no need to use VS Code anymore, I guess. Unless we want to like debug and like see how many examples we have or something. So I'm starting at 10:59. Okay, around 11 o'clock, and I'll see how long that lasts. I mean, if I want, I can like increase this number. I can like increase them both like a bit more, like increase the numbers of like simulations. I can increase the number of like games per iteration. I can even increase, actually no, number of iterations I'll just leave at one. Cause like each iteration is like when I run the node train dot whatever. I know I did like one and sometimes two for training Connect 4, but mostly I just did one. Okay, I'll just let this run. Maybe I could look into like, it might make sense to like run it here and debug and like kind of step through just in like Monte Carlo tree search, like just to make sure. Like one thing to do is like, I know one because we know it basically works for Connect 4, but like one difference we did is like in apply move, we passed in the prev game state, right? Like in train dot, well, in a, yeah, like apply move is not just like it's like we did a clone on the next game state, just refreshing my logic. Like these are like the lines that kind of changed that when we like shifted between Connect 4 and MCTS. I mean in BumperCoins bot for this file and train.ts, because like Connect 4 there's no notion like a game state is just the game state. It's like Markov. It's like it does not care about the past history. It's independent of that. Or like or I guess that's the same thing for BumperCoins, but like it's baked into the game state. Like the game state, its previous one is built into the game state, I guess. So then when we're applying the move, we have to clone it, obviously. But then we also pass in the, like, we clone it and then we take the clone, we apply the move on it, which is destructive operation. We also pass in what we want to backlink to. So like in apply move, like let's see that one. That one is used right here where we just like link it, establish the back pointer to that one. Then we toggle the turn and then we just return. after advancing it. So one thing that's a possibility to do actually is like, this is in the class game state. In this class game state, one thing we can do is add a new property called like, we can make this static or something like number of ticks or like tick count or just tick, right? Whenever we call apply move, we can like, whenever we're doing this update game state, what we can do is we can like increase like the tick count. So then like if the tick count like hits like some certain threshold, then we can just what do you call that? Like end the game as a draw. Wait, no, but then this thing gets applied a bunch of times when we're Monte Carlo tree search. No, I feel that that's the wrong place to do it. I think when we're like doing like the maximum count or something, that should be in train.ts when we're doing the execute episode or like when we're doing self-play game, right? I think here, like we should like this while loop while it's ongoing, we should like store the move count or something, like add a variable here called like move count. And then like every time in this while loop, you have to also do like the move count plus plus. And then at some point, if we hit like cross the threshold, we just end the game and then we just return the examples and treat it as a draw basically. And we kind of like break out of it early on and we just like jump to training it. Okay, have we finished the thing? Yes, we have finished it. The loss is 8.77. What was the loss there? 8.78. So like something changed. Status. Let's just do a get add all just so I can like save the weights. So in the future we can like see this weight change. And then like go back here. Do the old CP command. Actually no, get status. Let's just do a get add all. Get status. So now we have like the weights, but now when we do the CP, we should get the new weights. Get status. So as you see here, the weights have now changed. So get add all. Okay, yeah. So now the weights has reflected the new ones we copied over. Of course, we can run it again. I'm not sure we have to run it. I think it will dynamically load the new weights, right? I think the server is smart enough to see that the file changed and like it would give us new weights. But I'll still do run again. I feel it doesn't really make sense play against the bot because the bot is definitely like gonna suck like quite a bit. Yep, proceeds to hit the wall. It's already infinite looping. You know what, let's give this bot some depth actually. Let's give it some depth. Let's use Monte Carlo tree search in the bot. Actually, wait. Let me see how long how many ticks the bot takes again. Okay, 1 tick. We have 60 ticks per turn. Is this preloaded? Some font. Oh yeah, we have to like the first one is always super large, like 25. Like typically what people do in TensorFlow is like they actually like add some dummy prediction just to warm it up or something, do some warm up like tf.zeros, like create a dummy prediction just to like get the network warmed up or something, some like caching or some warming up. And then like the first one will always suck, like refresh. First one takes 31 ticks and the rest take like ones and zeros, like refresh again, 26 ticks and then like super fast. Like the first move, I guess, is like we should like make a warm-up call too. Like since asynchronous, we can like await on that too. So anyway, so I guess like for now I'll just end the stream, or actually let me just yeah, let's just end the stream and then off stream, like I guess next stream, maybe off stream I might do some training, and then also from like this side, rather than like greedily using the vanilla network, maybe I can also like incorporate Monte Carlo tree search. Also incorporate Monte Carlo tree search as well into this web page, so that like it should hopefully play a bit stronger then. Like we can see results faster. Like we can see improvements that our network. we can see them being reflected to us faster, basically, when we play against the bot. Because the bot will now have some depth, some look ahead by doing the tree search, MCTS. And again, because we imported our net.ts into it, it should be quite easy to just leverage the existing code. Like whatever we're doing in train.ts, right? Like in train.ts, in soft play, we're literally like doing the policy equals do MCTS of the game state in the model, right? So like what we can do here in MCTS, like we look at our to actually replace that from there and then go to our do MCTS, right? Oh, and this is optional too. That's the best part. So we can hard code and let the and we can let the user decide how many they want. Actually, before I end the stream, let me actually do that. So first thing we have to do is change this TF to TF.js and then just remove the node G. Okay, fine. Let's actually do that. Status declare Vim frontend client BumperCoins bot mcts.ts. Let's go here and let's kind of remove this node GPU. Status. And now let's kind of go into v frontend client bot worker. So now what do we want to copy over? We want to copy over in train.ts. It uses do MCTS. Again, this VS Code is in BumperCoins bot. So I'm like, yeah, this file is in BumperCoins. Do MCTS from not MCTS, but we have to kind of copy over like this prefix, right? Like that. So we copy do MCTS from BumperCoins bot MCTS. And then how do we be using it again? Do MCTS game state model. Let's put some space in. Let's comment this out, or actually no. Comment that out. Neural net. Now let's use MCTS. Let's let num MCTS sims number. Let's just set that to like 30, right? Like we found that everything takes like 0 to 2 ticks or like 1 tick, so 60. Let's make it like 25, or let's just do, yeah, let's make it 30. 30 ticks or so, or 30 simulations. And then now bot move is what? It's this do MCTS of the game state in the model. Same thing right here, basically. So that returns the policy. And then what we do again is the highest whatever that thing is from the policy, right? Just like that. Again, like if you look at this, that's in policy, right? The get highest whatever. We've seen that before in Connect 4. Sorry about that. Policy. Yeah, in the like we use sample move in the Monte Carlo tree search when we're training, but when we're actually playing, then we don't use sample move, which respects the move's probs. Instead, we just like, oh, this is a bad comment. I guess I copy pasted, but it gets the highest one, and that's what this does. You see this max prob equals prob? Like this was the fix that like this line was missing in the work from last stream. Like when I did what do you call that? Like this fixed bug in getting most promising move, I was missing like some line like this, which was causing like a non-random or like a very stupid behavior. So back to bot worker, what was I doing? Do MCTS. So I think that's it, right? Or no, we have to pass in the 30, or we have to pass game state model and what? Game state model optional is like number MCTS sims, which is their number MCTS sims. Yeah, exactly. I hope this works. So now basically rather than using the vanilla one, where now like the bot move is now like we're using it from Monte Carlo tree search. Let's hope this compiles. Yes, it compiled. Its status. I'm gonna restore staged front end client. I can just use wait stop in, get status. And now let's just commit only the get commit front end, or no, what am I saying? Get add front end client bot worker.ts, and let's do a get add of front end client BumperCoins bot mcts.ts, get status, and then like get commit use just use get logs here messages. Get commit, or wait, no, get status, get diff stage, see what we're changing, clear, too much clutter. So we just kind of like, we're leveraging this in fact, we can remove this one because it's no longer being used, this import statement. I'll leave it there. It's not hurting anyone. Do MCTS. So we're kind of like leveraging the existing thing in BumperCoins bot. So again, like if I find any bugs or whatever, then like I'll be fixing it in this direction. We reap the rewards for free. We do MCTS there. We can custom define again, like the idea is this should be user facing. The user should edit this number like we saw them do in Connect 4, right? We provide that functionality and do MCTS and we pass that in. It has probabilities. Okay, exactly. Yes. And then this is the only edit we have to make in BumperCoins bot, because we don't use GPU anymore. It's like Browserify. Our bundler is Browserify, and that just like it's able to understand like this. Well, TSC and Browserify work together to produce our bundle. Like TSC's like kind of runtime environment is not the browser. Its runtime host or whatever is actually like the platform is actually Browserify, our bundler, and then that one, whatever module system, I think they use like whatever they use, it just works. But we just have to delete that. That's the only change we have to make. It's okay, yeah. So git commit use MC or have bot use MCTS. Have bot use MCTS. That's a nice short message. Get status. We're ahead by 2. What are our 2 things again? Get log. And the weights I can change. In fact, now I'll add the weights. So this is like kind of like fixing a bug from this one, and we're kind of like using MCTS. And because our alternative stab copied and pasted or copied the whole BumperCoins bot thing, it was so trivial to make this commit. We just use what was already there instead of copying and pasting and making changes. We just do the convert to the BumperCoins, the game state bot or bot game state, and then we work in terms of that to get everything for free. So then that's all. Let's just do get status. Let's add the weights again. Get add all, get status. And then we can do a node train. Oh wait, no, I have to go to the other directory. And then do node train, or actually get status. Okay, and then we can do node train. And run this again. Oh, and meanwhile, let's actually go and like kind of play against the bot. Wait, never mind. Yeah, we were running a new one, right? I think now we're playing against the bot, which is using MCTS right now. Let's see how long it takes now, because it's using Monte Carlo tree search. Yeah, see? Now it's taking like 13 ticks, 17 ticks, 15 ticks, the first and 59. Like, you see how like now it's taking much more ticks than 0 and 1? That's because it's actually using Monte Carlo tree search. Like, let's actually look at that, right? Well, let's go to our sources. Or wait, I'm so used to Chrome. Wait, there's no web worker thing? Not this. Wait, what's this? Search for do MCTS. See the bot move now is so like we're converting it, we're linking it to previous, then we're taking that 30 and then we're doing the MCTS, passing in 30 here, and then we're getting the highest move. So like now it's doing some extra work. It's not just like the comments have been stripped out, I guess. But yeah. Okay. All right. That's good. That's good. So as we can see here, now it's taking like 13 ticks, 15 ticks, and so forth. So it's a bit later. Hey, now the bot's actually like coming closer to my king. See, my king is actually hurt a little bit. And its king is just, I mean, this is improvement, right? Like, yeah. Or not. Anyways, let's go back here. Okay, it's still training. It's still being trained. Actually, one nice thing, like I mean, node train is probably like the fastest way to do it but like if I do it in VS Code, like with a debugger, I can like kind of pause it and check the progress or whatever. But anyways, so they're just running. In fact, one thing I want to do, well, maybe not now. I'm pretty tired. I might stop soon. Is might just like run train one or two more times and just play against it. But like one thing I kind of want to do in the maybe just on stream or even off is like just like kind of like step through, like we were using Scratchpad to test, but we can also like I can also like kind of step through the code, like just put a debugger and like step through every single line of MCTS search. Even though I know I've stepped through it for Connect 4 and it seems to work, like it might be a good idea to just like do that. But I mean, if all the components work, if A, B, C, D individually work, then when you put them together, their combination should also work. That's like the whole idea of unit test or integration tests. Anyways, it's just running. 19. Maybe I should like use a time command to like see how long it runs. But again, in theory, if I've done everything correctly, then I just have to run this a whole bunch of times. In fact, rather than doing it a whole bunch of times, I can just like increase the size of like the number of iterations so that like I get it all for free, or so I don't have to do it once. I think I can use Caffeinate or something. Or maybe like if it's too slow, I can like rent some virtual machine or something and like with like a GPU or like something. I can like figure out some like hosting or I think like you can get like $200 of like free credits for Azure or something. I've already used my 300 for Google GCP, so I can't use that. But anyways, like the idea now is in theory, all I have to do is run this command a whole bunch of times, then play against the bot, and then hopefully like I'll get a decent bot. Like that's the dream. Like that's the end goal. But like in theory, if everything is being done correct, oh, it's doing training. What time is it now? So it's about like 2 minutes. I like the animation it has, 8.78 loss, and it's done. Okay, so now we have to go back here and do the whole CP stuff. I should just do get status. So right now we have some like staged weights, and after doing CP to get like the new weights, and now we look at get status, we will see now that we have like the weights have been changed a bit. So now we can just do a get add all, and we can just run it again. And now the idea after recompiling everything is like it will now like so now we can like play against the bot again. And now let's see if the bot plays any better. I don't know what the bot is doing. What happens if I put a coin near the bot? Yeah, just this time. I could just run that. Actually, I mean, I think I'm gonna stop now, do this a whole bunch of times off stream, and then report back with any improvements. And I may like, and if, yeah, I mean, yeah, there's nothing really interesting like looking at this happen. Like, it's just the loop, just keep doing it, maybe increase, like tweak some hyperparameters, like increase the number of simulations per like episode for each like get, whenever we're calling get move, like Monte Carlo tree search, we can maybe increase the number from 50 back to 500 or whatever, 1000 or something. Just tweak some numbers and like just keep doing this training stuff and like see if I get any improvements and report back, I guess. So yeah, I mean, I think this was pretty productive, like leveraging MCTS and like fixing, hopefully fixing the bug of like not linking the previous game state. And yeah, let's just see the like let's just like see the let's just like see all the get stuff we've done. So we've not really touched BumperCoins bot at all, but we have done mostly our work on BumperCoins, where we just kind of passed in the previous game state and then we updated to use Monte Carlo tree search, getting that for free because of our. So yeah, I think that's decent. I'll just end now, and then maybe do some stuff off stream too, just training, see how it goes. So yeah, later.